Hello everyone, my name is Mohammed Rilwan, a postgraduate student, Department of Statistics, Nasarawa State University, Kefi, Nasarawa State, Nigeria. My supervisor is Dr. Mary Uneku Adey. Today I am going to share with you what my research article is all about. The title of this research article is Meta-analysis on the effect of Tamiflu in patients infected with flu in some areas around USA and Asia. This research article was published in International Journal of Science and Research on 6 July 2021. To cite this research article, go to your browser, type in meta-analysis by Rilwa. My presentation plan for this video, we are going to look at introduction to neuraminidase inhibitors, methodology, estimation of the model parameters, data presentation, and finally, the conclusion. Introduction to flu infection. Flu infection is also known as influenza. Influenza is an infectious disease caused by a virus that can be deadly, most especially in high risk groups. These high risk groups include young children, older adults of 65 years plus, pregnant women, and people with weak immune system. Flu infection antiviral agents are Tamiflu, Zanamivia, etc. of the neuraminidase inhibitors class. These agents are commonly used as stockpiled drugs employed against seasonal and pandemic influenza on the basis of international and national recommendations. These recommendations are based on the claimed and assumed ability of the drugs to reduce complications and transmission of the disease. Neuraminidase inhibitors are also known as antiviral agents. These antiviral agents are a class of antiviral drugs which block the function of the viral neuraminidase enzyme. By blocking this enzyme, it stops the release of viruses from the infected host cell and prevents new cells from being infected. These antiviral agents inhibit all subtypes of neuraminidase enzymes and therefore are effective against influenza A and influenza B viruses. Tamiflu and Zanamivia were approved in the United States and Europe for treatment and prevention of influenza A and B viruses. The scope and limitation of this research article uses random effects model meta-analysis to evaluate the effects of those neuraminidase inhibitors or antiviral agents on the duration of flu symptoms relief in adults. This study focuses on Tamiflu among other numerous antiviral agents or neuraminidase inhibitors. The Tamiflu. Tamiflu is an antiviral drug that is prescribed to deal with the influenza. Tamiflu is now on the list of World Health Organization essential drugs, but we could not clarify on what basis World Health Organization or the Centers for Disease Control and Prevention recommends its use. In 1999, Tamiflu and Zanamivia have received Food and Drug Administration approval. The historical background of flu infection. The 1918 influenza pandemic was the most severe pandemic in recent history. It was caused by an H1N1 virus with genes of avian origin. Although there is not universal consensus regarding where the virus originated, it is estimated that about 500 million people become infected with this virus. The number of deaths was estimated to be at least 50 million worldwide, with about 675 occurring in the US, Mortality was high in people younger than 5 years old, 20 to 40 years old, and 65 years plus. The high mortality in healthy people, including those in the age group 20 to 40 years old, was a unique feature of this pandemic. This research work aims at describing the effects of neuraminidase inhibitors or antiviral agents on the duration of flu symptoms relief in adults by reviewing the neuraminidase inhibitors, specifically Tamiflu, for use in treatment and prophylaxis of flu infection. To achieve our aim, we applied random effects model meta-analysis to estimate the variance of the distribution of true effect size that describes the variability of effect size and between study variance. Secondly, we test the significance of the model coefficient on first, the effect of the drug on the mean time to relief. Second, the potential impact of the drug in all populations. Data description. The data used in this research article was reported from Cochrane library database containing neuraminidase inhibitors for treating and preventing influenza in adults and children that was recorded in some American and Asian countries in the year 2014 by Tom Jefferson and co. After I reviewed the original article, I found out that nothing was discussed about the variability of effect size across studies and the between study variance. So, in this research work of mine, we have reviewed why and what are the causes of variability of effect size across studies and the between study variance. This research uses random effects model meta-analysis to understand variability of effect size across studies. In previous researches, they used fixed effect model meta-analysis to evaluate the effects of neuraminidase inhibitors on time to first alleviation of symptoms. But as I said earlier, nothing was discussed about the variability of effect size across studies and the between study variance. The variability of those effect size across studies is meaningful for future research. So this research work investigates why and what are the causes of those variability of effect size across studies and the between study variance. Hopefully, this will lead to a new better way of preventing and treating flu infection globally. This research work is going to be significant to health sectors, government, and researchers. The outcomes of this research work will inform and educate the general public, especially those within the health sector. Also, it may lead to further research in the future, which will greatly improve the diagnosis and treatment of flu infection, especially in countries where there have been great deaths due to the disease. The research article has the following questions. The first question is the impact of the drug consistent across studies or it varies? The second question is why the estimate of standard deviation is zero? So we are going to look at this towards the end of the video. The reported data consists of 8 studies. Each study reported mean time to relief, standard deviation, and the sample size. The outcome of this data set is mean time to relief. The effect size is simply the difference in means. Patients who had recently been diagnosed with flu infection were randomly assigned to either the treated group or the control group. The treated group was given Tamiflu and the control group was given a placebo. The method of data analysis based on the objectives and research questions of this research article, the method of analysis employed is random effects model meta-analysis. The data was analyzed using comprehensive meta-analysis version 3 software. Meta-analysis is a statistical analysis that combines the results of multiple related already analyzed scientific studies that are addressing the same research question into a single estimate known as the summary effect. Meta-analysis are widely used in the fields of medicine and psychology to synthesize qualitative information from related studies and produces results that summarize a whole body of research. So meta-analysis can be defined as the analysis of variance. You already have analysis of variance, you perform another analysis. So you can call it analysis of variance. Meta-analysis has two models, the fixed effect model and the random effects model. Random effects model meta-analysis allows that there is a distribution of true effect size that the combined effect or the summary effect cannot represent, rather represents the mean of the population of that true effects. So the model is given as T sub I is equal to theta sub I plus epsilon sub I, where T sub I is the observed effect size, the estimation of the model parameter to estimate the effect size. The formula is given as this. To estimate the within study variance, the formula is given as this, where the formula for standard deviation of within participant is given as this. To estimate the standard error of dm, the formula is given as this. To estimate the variance of the distribution of true effect size, the formula is given as this. To estimate the study worth, the formula is given as this. To estimate the summary effect, the formula is given as this. To estimate the variance of the summary effect, the formula is computed as this. To estimate the standard error of the summary effect, the formula is given as this. To estimate the 95% confidence interval for summary effects, the formulas are given like this. To estimate the z-value, the formula is given as this. To estimate the p-value for statistical tail test, the formula are given as this, where pi of z is the standard normal cumulative distributed function. Data presentation. The outcome of this research article is mean time to relief. So a lower number indicates effectiveness of the drug. The effect size is simply the difference in means. Patients who had recently been diagnosed with flu infection were randomly assigned to either of two groups. The treated group that was given Tamiflu and the control group that was given a placebo. The article consists of 8 studies. The first study is M76001. It reported the mean time to relief, the standard deviation, and the sample size. The mean time to relief in the first study is 140.6 hours, and the second mean in the control group is 165.5 hours. So if you take the difference between the first mean 140.6 and the second mean 165.5 hours, the outcome will be negative. So this is what we expect to see if the drug is effective. So the first study M76001, the effect size is negative 24.9, approximately about 25 hours. So this is what we expect to see if the drug is effective. And all the effect size are less than 0 except for the fourth study. So in most studies, the treatment group reduced the time to relief. The row for each study displays the results for that study alone. For the first study, Tamiflu reported 24.9 hours sooner than the placebo group. But as always, the difference in the sample is only an estimate of the difference in the population, and it's the population that we care about. So, in the population from which this study was drawn, the difference probably falls in the range of 8.6 hours to 41.1 hours. In round numbers, the drug speeded up relief by at least 9 hours and possibly as much as 41 hours. In that range, the confidence interval does not include the null hypothesis. So the difference will be statistically significant. Similarly, the p-value for this particular study is 0.003, which is also statistically significant. Similarly, we can look at other studies in the same manner. The results were statistically significant in only two studies. In others, the confidence interval includes the null hypothesis, and the p-value are not statistically significant. That is how we explained 95% confidence interval in analysis of variance. But since meta-analysis is a analysis of variance, for a meta-analysis, we defined a universe of populations and then draw sample of populations from that universe. The mean effect size is 16.759. However, we don't care specifically about these eight studies. Rather, these eight studies have been sampled from a universe of studies, and we want to know the mean in that universe. So the 95% confidence interval from that universe of studies is 25.1 hours to 8.4 hours. So in this universe of studies, the mean difference is probably at least 8 hours and possibly as much as 25 hours. Test of null hypothesis, we have the null hypothesis to be the mean difference in the universe of studies is 0 hours against the alternative hypothesis that says the mean difference in the universe of studies is not 0. Since this range 25.1 hours to 8.4 hours does not include the null hypothesis, the difference is statistically significant, and similarly, the p-value for this summary effect is less than 0.001, which is also statistically significant. We reject the null hypothesis that says the mean difference in this universe of studies is 0 hours and conclude that on average, Tamiflu reduces the time to relief of symptoms. Similarly, for case 2, we can test the null hypothesis that says the mean difference in the universal population is 0 hours. The z-value for this test is 3.9 and the corresponding p-value is less than 0.001. We reject the null hypothesis that says the mean difference in the universe of population or of the distribution of true effect size is 0 hours and conclude that the mean effect size is not 0 hours. On average, across all relevant populations, Tamiflu reduces time to symptoms relief. To answer our research question, we have to look at the heterogeneity of effect size. This is the dispersion in effect size. We have Q value. Q value is a sum of square deviations on a standardized scale. It captures the deviation of every effect size from the mean effect size. It does this relatively to the standard error of that study alone. Large deviation is discounted if the standard error of that study is also large. The sum of this square deviation is 6.325, and the df of q is the degrees of freedom, that is, number of studies minus 1. The degrees of freedom is also the q value that we would expect to see if all studies were drawn from the same population. If q value is greater than the degrees of freedom, then the dispersion that we see is more than we would expect to see based on sampling error. In that case, we proceed to compute the variance of the effect size. But in this research work of mine, Q value is less than the degrees of freedom. And it turns out that the amount of dispersion that we see is actually less than we would expect to see based on sampling error. In this regard, we estimated the variance of the effect size and the standard deviation of effect size as zero and conclude that there is no evidence that the effect size varies at all. So when talking about the potential impact of the drug, we can assume that it will be pretty much the same for all populations. To answer question number two, we have to look at forest plot. This is the forest plot. The forest plot shows the variance in the samples, but we are estimating the variance in the underlying populations, that is, universe of populations. Suppose that we have selected one population and then drawn 8 samples from that population. If the effect size in that population was 16.759 hours, then by definition, the population effect size for all the included studies will be 16.759 hours. So we were not expecting the observed effect size in each of the studies to be precisely 16.759 hours due to sampling error. The observed effect size in some studies would be less than 16.759 hours, and in some population will be more than 16.759 hours simply because of sampling error. Indeed, if the observed effect size in all studies was precisely 16.759 hours, then we would assume someone had fabricated the data. Thank you for listening.